Hi there. My name is Jeff Martins, and I'm the CEO and co-founder of Metrist. You know, we all strive to provide high availability for the apps we own. And frankly, our industry does a pretty fantastic job of that when you step back and you look at all that goes into delivering modern software. Today's apps are wildly complex, and they're better thought of as webs of functionality working together to provide an end product. And all the complexity, it impacts our ability to set appropriate SLOs and to deliver on the SLAs we promise. Availability of the dependencies we commonly rely on will have a surprising impact on the availability of any product. Through my work in the monitoring and incident management space at New Relic, PagerDuty, and now at Metrist, I found that the availability of dependencies, especially that of third-party software, has an impact that is often overlooked and misunderstood. The reality is that a bunch of apps with 4 nines does not necessarily result in a product with 4 nines. So over the next 20 minutes or so, we're going to use simple math to uncover the realities of SLAs and complex systems. And we're going to learn how we can use the concept of a composite availability to better understand our risks and use that information to set more realistic and manageable SLOs when your app relies on a bunch of other apps. All right, let's jump into it. And I want to start out with something that might seem rather simple. And in fact, I'm pretty sure you know the numbers I'm about to show you. Somebody might have mentioned them in a meeting sometime recently. And I'm probably not even the only person at PagerDuty Summit that's putting them on their slides. But I think they're really important context. So I want to spend just a minute talking about what sort of downtime we can expect when we measure our availability in nines. So let's start out with 99.99% availability. That's 4 nines. That's typically kind of what the industry aspires to do. And when we do that, we're looking at only 52 minutes of downtime per year. That's less than 5 minutes per month, and that's really impressive. So now let's jump down to 99.9% availability. It's a really impressive number still, and it even sounds better. 99.9%, that's a lot, right? Well, this is where things start to get kind of interesting. When we deliver 3 nines of availability for our apps, we're looking at having as much as 525 minutes of downtime per year. That's nearly 9 hours. Now, I want to talk about 99%. I know most of us aren't aiming for that, and we're probably doing a lot better than that. But I think it's important to set that context. 99% availability means 1% downtime throughout the year. And over those 12 months, that's a whopping 5,256 minutes of downtime, nearly 88 hours worth. So before we move on, I just want to say, if you're delivering 4 nines or anything close to it, congratulations. You're doing something that's really hard. And we're going to see in my next few slides why it's so hard to deliver that set of reliability when we have apps that are built on top of other apps. Okay, so to get into the next section of our talk, I want to start out with a really simple example of an app. Now, we're actually going to start out with a user. This user is interacting with a product, and that product promises 99.99% availability. And now that product is backed by a single piece of software, one monolith that does everything that that product needs to deliver that user experience. Now, in this overly simplified example, it's really easy, actually, to deliver 99.99%. The one piece of software we have only has to be available 99.99% of the time. And then that's what the user experiences. It's pretty straightforward, right? Well, the reality, of course, is that very few of us are delivering user experiences and products that are backed by only one piece of software. Even if we maintain a monolith that's the core of the application, we probably have at least 2 other microservices that do some other things, right? So let's take a look at something that might be a little bit closer to what our reality looks like. In this case, we're going to take the same user, still accessing a single application. And this time, instead of having one piece of software that backs that product, we now have 3 pieces of software backing that product. And we're going to say, for the sake of demonstration, that all three of those pieces of software independently are delivering 99.99% availability. So with that knowledge, it would probably be pretty easy for us to jump to the conclusion that if we want our product to have 99.99% availability, well, it will, because all the pieces of software that underlie it have 99.99% availability, right? Well, not exactly. And this is where things start to get pretty interesting, even though it only takes simple math to understand them. See, when we want to understand what the product's availability will be when it has three services, we actually have to multiply the availability of all three services together to get something that we call the composite availability number for that product. So we multiply 99.99 times 99.99 times 99.99, and what we learn is that we're going to have a product that can promise only 99.97% availability. And this is pretty surprising, right? Because we have three apps with 4 nines, but our product only has 3 nines and an extra 0.7 or 0.07 to go along with it. Well, the reason that is that we have to understand the likelihood that all three of these services are going to fail at the same time. Because we know outages are going to happen. And while we may like to think that they're going to happen at the same time, probability tells us that these three services are going to fail at different times. And you're probably wondering, well, I know that. How do we know that probability will tell us that? Well, again, it's just simple math. This time, instead of multiplying 99.99 times each other 3 times, we're actually going to do the inverse of that. We're going to take the availability, and that's going to be 0.01%, and we're going to multiply it by itself 3 times. And that's going to give us the likelihood that all three services are going to fail at the same time. And that's what has to happen if we expect our product to have 4 nines of availability, just like our microservices do. But when you do that math, you'll find that it is very unlikely that all three will fail at the same time. And it is still highly unlikely that 2 of the 3 will ever fail at the same time. And that is why our product has only 99.97% availability, because we're going in with the understanding that these failures are probably going to happen independently. And that means our product is going to be impacted up to 3 times more than it would have been impacted had it only relied on one piece of software, like our first example. Okay, so we're starting to understand how the math works. I promised you it was simple, and I'm sure you see that now. But we're still not talking about a very realistic example. I don't think many of us in this room are delivering products that only require 3 pieces of software to do what they do. So let's take a look at something that is a little bit closer to reality. You know, in reality, our systems, they probably include dozens of microservices. And that's going to vary from company to company. In fact, I reached out and I asked my network, how many services does your organization maintain to deliver the product that you work on? And I got a bunch of answers, and they were all over the place. And a couple interesting data points for this. The first is that the answer with the smallest number of microservices to deliver a product was 4. And that's more than our last example. But the highest number was 2,000. Somebody said that their org maintains 2,000 different pieces of software to deliver the application that you and I have all interacted with at one point in our lives. But guess what? It's not just those microservices that our org maintains. We also have to start to think about all of the external services that we utilize and reach out to deliver the functionality that our customers and users expect. Things like payment processing APIs, or reaching out to another service to get information about mapping, or maybe even a third-party messaging service. And of course, don't forget all of the compute and storage products that we utilize from companies like Amazon Web Services in order to run the apps that we build and maintain. So with all that said, in the next slide, we're going to jump into something that's probably a little bit more realistic, but honestly still simplified from what most of us experience in our day-to-day work. So in this case, we're going to assume that we have a user still interacting with a single product, but now we're going to have 5 microservices that our org builds and maintains. Those microservices, we're going to say that they have a 99.9% availability, which is pretty good, as we saw earlier. Now, to make things a little bit more complex, but to make things be a little bit more familiar with what you're used to, we're going to assume that 3 of those microservices also reach out to external third-party services to do what they do. So now we have to consider what is their availability. And for this example, we're going to give them the benefit of the doubt, and we're going to say that those 3 external services are delivering 4 nines. So now we have a system that has 5 internal apps, 3 external apps, and across those 8, they're delivering either 3 nines or 4 nines. So now, what do we think the availability is for the product that all of those things work together to deliver? Well, again, all we have to do is use simple math to create a composite availability number. And in this case, what we'll do is we will first bring together the 2 availability numbers for the microservices and the third parties that they reach out to and create a composite availability for those. And then once we have those 3 composite availabilities at that layer, we'll multiply them all 5 numbers together in order to get our composite availability for the product. And with that, we're going to see that an application that relies on 8 services delivering 3 nines or 4 nines itself can only deliver 2.5 nines of availability to its end users. Now, this number is probably pretty scary, right? You're looking at that going 99.5%. That's a lot less than my company promises, and it's a lot less than I would expect. And that's a lot of downtime, over 2,000 minutes a year. And you're right, all of that is true. But there's an important thing to remember here, and that is that composite availability is not meant to be the same thing as your SLA. With composite availability, what we're trying to do is understand the worst case scenarios and having a view on how all of the different services that we rely on might impact the end user's experiences. Now remember, SLAs, those are just targets that we aim for, and they typically are consequences that are pre-laid out in case we don't meet those targets. Many companies do better than their SLA. And yes, some companies, they do worse. But with all that said, you're probably saying, okay, Jeff, why does this matter? Why are we talking about it if a composite SLA or composite availability is not the same as the SLA that my customers see and experience? Well, I hope that this time we're spending together at PagerDuty Summit can be an opportunity for you to be motivated and to go out and say, look, I want to understand the composite availability of my apps. Because when you do that, I think you're going to be surprised at the impact that a lot of things can have on availability. And these are things that are way down the stack that you might not even know about because they're a dependency of a dependency of a dependency that you have. So if this is something you want to do, if you want to understand where the risks and opportunities are with your app and what it might look like if every service you relied on went down as much as they say they might go down, my next set of slides is going to be some tips on how you can calculate composite availability for your product. All right, let's jump into it. Doing this is really easy, and it's probably things that you're familiar with. But I hope I can point out a few things that you maybe didn't expect or think about. Now, the first thing you're going to do if you want to calculate the composite availability of your product is to go out and try to understand every single service within your organization that your product relies on to deliver a user experience. For some of you, this can be pretty easy. You can just look at a service directory and you're going to have a list of applications, who owns them, what's their availability, and what depends on them. But if you're like some other people, you might have to go put this together yourself. You're going to have to remember what they are. You're going to have to look through your code to uncover them. You're going to have ask other people around your organization what things they depend on. And you're going to write all of this down until you've painted a picture of what your internal service dependencies look like. And this could be a significant effort, but I promise you it'll be worth it because you're going to understand your system in a way that you never did before. Okay, so once we have all of our internal services mapped out, the next thing for us to do is to uncover all of our external dependencies. Remember what we talked about earlier? It's not just the apps that we build and maintain, it's also all the apps we reach out to. If you use something like Okta for customer authentication, add that in. It's an external dependency. You use Stripe for payments, Twilio for messaging. So these are all external dependencies that many of us rely on, but we often forget about them when we're talking about reliability and risk to our systems. So start uncovering all of them. And there might even be more than you would expect. Through our work at Metrist, we found that our typical customer is using about 40 different third parties to deliver their software product to their customers. A number that surprised us, but it's only growing over time. Okay, now that you know all your internal dependencies and you know all of your external dependencies, the next thing to do is to figure out what is the SLA on all of these things. And this is where I'm going to have my first set of good news and bad news. And the good news is for your external dependencies, it's probably pretty easy to find out what number they promise to deliver you when it comes to availability. For some companies, it's public on their website. For others, you can look at it when you log into the product. And for a whole bunch more, you're probably going to have to go dig through the contract that your boss signed about 11 months ago. But it's okay because this data is data that is available to us and it can be tracked down. And I believe it's critical that you understand the reliability that they're providing so you can understand what your composite SLA is. Now, the bad news comes with some of your internal services. And that sounds funny. You might think it would be easy. But what I found is a lot of teams and a lot of services don't have an SLA for their internal customers. So this is an opportunity for you to start talking to folks on the other teams. And yes, I even mean your buddy that works on that team that you work so closely with and you have lunch with once a week. You still need to get a hold of them and ask them, hey, what's the SLA that I can expect from you? Because SLAs are not just for paying customers. You can and you should have an SLA for every service you depend on, even the internal ones. Okay, so we now have our internal services mapped out. Our external services have been uncovered or written down, and we know what the promises are for availability of all these services. My next piece of advice is going to be a little unorthodox, so I'm just going to say it. I want you to push those SLAs to the side, throw them away. Okay, well, don't actually throw them away because you may need to use them later, but we'll get to that in a few minutes. But the important thing to remember here is SLAs do not equal availability. As I mentioned earlier, SLAs are simply promises with consequences outlined in case that promise isn't met. But it's oftentimes really hard to know, did they deliver on that SLA? Did they do better? Did they do worse? And what I found is most people really don't know the answer. But the good news is that is an answer you can get. And that leads me to my next point on our fourth step, and that is we need to start measuring the availability of all of the services we depend on and not rely simply on a promise that they've made that may or may not be opaque. Now, we're back to my last good news, bad news scenario. The good news is if you want to understand the availability of all the internal services you rely on, I'm pretty sure you can get that easily. Most of us here today, we can open up our work laptop, we can go to a Datadog or a New Relic dashboard, and within a few clicks, we can probably find what the uptime or availability, if you will, was for every service we rely on the last month, the last quarter, or even the last year. The bad news is when it comes to all of those third parties, getting actual performance and availability data from our third parties can be really, really tough. But it's so important because we found through our work at Metrist that between 30 and 70% of customer-facing downtime comes from external third parties. So while it can be hard to get, there are a few things you can do. The first one is if you spend a lot of money, you could probably just ask your sales rep or your TAM, and they'll tell you because they value your business and they don't want to lose it. But if you're like the rest of us, you're going to have to rely on what's publicly out there. Now, there are a few companies that do a good job. GitHub, for example, is wonderful about being transparent and putting it all out there for you. But most other services, they aren't so good. And that's where we have to start considering monitoring all of our external third parties in a similar way that we monitor all of our internal services, whether they're the ones we own, first-party services, or the ones our colleagues own, the second-party services. And that's where you're going to want to take a look at the concept of synthetic monitoring. And synthetic monitoring gives you an opportunity to view a service's functionality, performance, and availability from an unbiased point of view. It's not a metric from within your application logs and metrics, and it doesn't get impacted by the way you implemented a service. Synthetic monitoring can give you a true look at how a service actually performs without you having to catch them in downtime, which most SLAs require, and without having to trust that they're going to tell you when they had a problem when we all know they rather would not. Okay, so you've uncovered your service dependencies internally, you've mapped out all your external service dependencies, you've collected SLAs in case we need them, but since they're not very good for us, we started monitoring all of our services so we can understand the actual availability. And that leads us to our last step, and that is simply to calculate the composite availability in a bottoms-up fashion. And what I mean by that is start at the layer of your system that is as far away from the user as possible. That's typically going to be with an external third party, where one of your services within your org reaches outside to an external third party. Calculate that internal services composite SLA, and do that and work your way up the chain until you get to the top layer of services that all directly impact your customer's experience. You're going to multiply all those numbers together like we did earlier, and you're going to get the composite SLA of your product. Now, I know you haven't done this yet, but when you go back to your desk, you're going to give this a try, and you're going to see something that's going to be kind of shocking. You're going to see a number that looks pretty low. And maybe even more scary, it's not going to be anywhere close to the SLA that your company provides to your customers. And I'm here to tell you that both of those are perfectly okay and they're expected. Because as we said earlier, composite availability is not the same as an SLA, and it shouldn't be. I'm not here to tell you that there's a better way to do SLAs. I support the way we do SLAs today, and I'm not trying to get you to change. Our SLAs today typically cover very specific critical paths of functionality within our apps, and that's what they should cover. And the composite SLA doesn't mean that your app's actually going to perform that bad, but it is showing you what the worst case scenario is. And more importantly, it's uncovering the areas of opportunity where you might discover that dependency, possibly outside of your four walls, is 3 layers deep and has a really surprising impact on the availability of your product. That's why we do composite SLAs. It's not meant to be a better SLA for your customers. It's a very different thing. Okay, with that, I'm going to wrap things up, and I'm just going to cover over some of the things that we just learned. A few things to keep in mind from today's talk. Downtime, it's going to happen. And understanding that downtime for complex systems is pretty hard. SLAs, setting an SLA in a complex system is not very easy either. And if we want to better understand where our risks and opportunities are, we have an opportunity to calculate the composite availability of our products. But in order to do that in a way that's realistic and meaningful, we can't just rely on opaque promises that are sometimes called an SLA. And instead, we need to use actual data that defines the true functionality, performance, and availability of the internal and external systems that we rely on. And when you do this, I promise you're going to walk away more enlightened into how your system works with ideas on how you can improve the uptime and reliability of the product you deliver. And finally, I want to recognize somebody that did some writing that helped give me a language to talk about this concept that I've been thinking about for so many years. Alex Yerloff, if I'm saying that correctly, is a staff software engineer at Volvo. Alex writes over on Medium, and recently Alex posted a blog post called Calculating Composite SLA. And I enjoyed reading it so much, and I felt so seen based on everything that I've been thinking over the years. And I have since used his terminology, composite SLA, in this talk. So I want to thank Alex for inspiring me. I think you're going to like his writing as much as I have. And Alex, if you're watching this, thanks so much for all you do for our industry. All right, that's it for me today. Again, my name is Jeff Martins. If you have any questions, if I got anything wrong, or you just want to discuss this some more, I'm at jmartins on Twitter. And if you're struggling with understanding the actual availability, performance, and functionality of your external dependencies, come check out what we're building over at metris.io. That's it for me today. Have a great day.